Hi folks, so you're at home and I'm here and we're going to do a relatively brief recording of the knowns for, of the knowns, for group 2 and for group 3-4 cations. Now I mentioned in lecture, and hopefully you paid attention to this at the end of chapter 17, about the selective precipitation of cations. We also talked about how you can change the solubility depending on the pH. In other words, how well is this going to precipitate at certain pHs? We can change the solubility if we form complex ions. We're going to use all of that. Now, I talked about this in the concepts video. So if you haven't watched the concepts video, you should shut this off and watch the concepts video first, because I'm not going to go through all that again. Our group 2 that we're going to be starting with this particular film is a pale blue solution. This is the knowns, and it contains all 4 of the group 2 cations that we're going to be using, that are safe to use. Bismuth 3+, tin 4+, cadmium 2+, and copper 2+. Now the first thing we're going to do is drop the pH, or have the pH really low, and we're going to form some sulfides. We want this pH really low, very acidic, to form sulfides, because at really low pHs, these other group 3-4s cations, and we'll talk about those in a little while, won't form sulfides at a very low pH. So the first thing we're going to do, adjust the pH so it's really low and it's the right pH. And then we're going to add something called thioacetamide. Again, I talked about this extensively on the concepts video. So all I'm going to tell you is that thioacetamide does break down upon heating to form hydrogen sulfide. Why we do this in the hood, right? Hydrogen sulfide is very nasty, stinks, and will kill you. So we do this in the hood. But anyway, so thioacetamide in the bottle isn't going to kill you. So we're going to put that in acidic solution, and then we're going to put it in the hood. We're going to heat it in the hood, break down that thioacetamide, and use the resulting hydrogen sulfide to form some sulfides of our group 2. Again, at low pH, the only things that are going to form sulfides are these group 2. So we're going to form sulfides in this precipitate area. We're going to have bismuth sulfide, tin sulfide, cadmium sulfide, and copper sulfide. All of those will be in the precipitate, and it's going to be black and disgusting. We're going to spin it down, this black and disgusting solution, spin it down and take off the supernatant, which with the unknown will contain some other cations. For this first video, it will not. It'll just have water. All right, after we have got these precipitates isolated, we're going to adjust the pH. We're going to put the pH up a little bit, obviously, since we're adding KOH to it. That's a base, so we're going to tip it up a little bit, and a really cool thing happens. Now, technically, tin sulfide should stay as a precipitate. And if you had it in ammonia or other bases, it would. But tin forms a complex ion with hydroxide. Remember, complex ions just love to stay in solution, aqueous. They allow you to dissolve things that are insoluble otherwise. So tin sulfide reacts with the hydroxide and forms this aqueous complex ion. It's yellow. So again, first, bismuth sulfide, copper sulfide, cadmium sulfide don't break down, don't form a complex ion. They just stay as they are. So we're going to centrifuge this. We're going to have a supernatant. The supernatant is the aqueous solution on top of the precipitate pellet. And you'll see that today as we go through this experiment. So we're going to pour off the supernatant. You're going to decant, pour that supernatant into another test tube without removing the pellet. And then we're going to take that pellet and add some hydrochloric acid and some more thioacetamide to return it to this murky yellow tin sulfide. And that is our affirming test or confirming test for tin. Meanwhile, back in the test tube, we have these sulfides still. Okay, we've finished with tin. When you're done tin, you throw it in the waste container. So back at the ranch, we have these other sulfides. We're going to acidify it again because we really don't want to deal with a basic solution except for tin. And when we acidify it to a certain extent, especially with HCl, not nitric acid, not sulfuric acid, HCl, the cadmium forms a complex ion with chloride. And it dissolves. Okay? So now we have this cadmium chloride complex ion that is in the supernatant, it's aqueous, and our bismuth sulfide and copper sulfide are still hanging out as precipitates because they don't form complex ions with chlorides. So we're going to take care of cadmium first. Cadmium's already in solution. We're going to take this, centrifuge it, you're going to see this all today, spin it down, you'll end up with a supernatant and a precipitate. We're going to decant the supernatant off, and that's what we're going to play with first. We're going to add some ammonia, pump up the pH a little bit, and add thioacetamide. And we're going to get our cadmium sulfide back. This is a pale yellow precipitate. This is murky brownish yellow. This is pale yellow. And we may or may not be able to get it because it's very, very finicky. But anyway, that's a precipitate. So now we're done with this. We're done with this. We just have these guys, bismuth and copper sulfide. So first thing we're going to do is add some acid. Now notice this is not chloride, this is nitric acid. And when we do this, we are going to break down both of these. They're both going to dissolve. What won't dissolve is garbage. Okay, so you may have a little floaty garbage floating around. Who knows what it is? You got to take it out because it's going to interfere. Okay, we'll show you how to do that. So your solution, you're then going to add ammonia to, and this is really cool because ammonia makes stuff basic, but it also makes a complex ion with copper. And you've actually seen this complex before. You saw it back at the beginning of the semester when you dealt with copper, and it's like a dark purpley blue almost. It's a very vibrant blue. And that's all we use. We don't take it back to a sulfide. We just see that bright blue and boom, that identifies copper. The precipitate, meanwhile, why is it a precipitate? Why didn't it? Because it doesn't form bismuth doesn't form a complex ion with ammonia. Bismuth, however, when you raise the pH, forms this really nice little white precipitate, bismuth hydroxide. Okay, so that's following the flow chart. Now let's actually take it over to the lab bench and go through this bit by bit.
All right, hi everybody. Professor French walked through the scheme on the board with you, but now I will be showing you, at least in part, how to do the experiment. Professor French might take over later. We're kind of tag teaming this. But to start with, like we said earlier, here is our pale blue solution of our group 2 unknowns. I'll hold it to my white jacket so you can kind of see the color there. Got a nice pale blue color going for you. So what I'm going to do is I'm going to add, so I've already pre-made the dilute ammonium chloride.
No,
just ammonia. I'm sorry, just the dilute ammonia. And I've already made it here, so I'm going to add it dropwise with my pipette to this until we get a nice cloudy color. So, here you go.
Yeah, zoomed in.
You can already see some cloudiness showing up.
Oops, a little too close.
I think that's a good amount of cloudiness.
Yeah, you gotta shake it and make sure it doesn't all go away.
All right. Let's give that a good shake.
So when it does that, it's now too basic, so now we have to add, which is what we're going for.
So now that we've over-basified it, which is what our goal was, we got that nice, still kind of...
Hold it down a little more.
Still...
I gotta back it up. There we go. Sorry, guys. Okay.
This is a learning curve for us.
Yes,
So
I've
now that
never
we've made
done
it
this.
basic and got that nice cloudy color, we're going to add some of our 6 molar HCl. In theory, I should only need 1 drop of this, but I might have put a little extra NH3 in there, so it might take more than 1 drop. So let's see what happens. Oop. That was 2 drops.
Back up a little more. It's getting there. It's getting there. Ooh, pretty. Nice and clear.
Yeah, so that looks about good to me. Once again, hold it up to my white shirt. You can still kind of see it's a pale blue color, but we've gotten rid of all of that. So now,
It's at the right pH.
it's at the right pH. So what am I doing next? I'm adding 10 drops of thiocyanamide. So here's my thiocyanamide bottle, and we're going to add 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Everybody at home go, ew.
Yeah, so now you can see a nice distinct color change there. We still kind of got that pale blue solution on the bottom, got a layer of our white cloudiness, and we got a nice yellow color up top. And I'll give it a good shake to mix it all together now. And now we've kind of just got a uniform, cloudy yellow color. Doesn't that look beautiful? Very colorful lab. Yeah. So now I'm going to take this and I'm going to put it in the heat bath for 10 minutes. The water bath is over in the hood, so we're going to pause the video, and when we're done heating it, we'll come back. All right. So I just took this out of the hot bath. I'm holding it in my little test tube holders because I just took it out of the hot bath. It's hot. I don't want to hold it with my bare hands. And we got that like icky black color. So when we heated it, it started to do some stuff, and we got a nice black color.
Those are all our sulfides.
And these are all our sulfides that should have precipitated out of solution. So now we're going to put this in the centrifuge, and we're going to spin it down. That's cool enough for me to hold now. And we're going to spin it down. And we'll centrifuge it for a handful of minutes. We're not going to make you sit there and watch the whole centrifuge process. So once I get this running, we'll do a jump cut to when it's over. Alright, so now that we've centrifuged it, we've got our nice black precipitate, and I'll hold it up to you. And we have a solution in there, kind of like a dirtyish, brownish yellow color, but the precipitate is the important part. We did notice that the instructions say that we should have put a drop of ammonia in there, which we did. We just forgot to record it, so know that we did that. But anyway, now that we have our precipitate, we're going to add 5 more drops of the thiocyanamide, and then we're going to put it in the heat bath, add some more ammonia, and centrifuge it. So we'll decide how much of that we show you, but that's what's going to happen next. So 5 more drops of this. 1, 2, 3, 4, 5. If you look closely, kind of got a yellowish solution sitting on top. Give it a good shake, mix it all in there. And we go back to our kind of dirtyish solution with the black precipitate at the bottom. So this is just to help kind of precipitate whatever's left in there out so we can get as much as we can out of this. So I'm going to go put it in the hot bath, and we'll see you in a little bit. Alright, so we did all those stuffs, we heated it, added the extra drop of ammonia and centrifuged some more, and now we've got this bad boy right here. And we've got a whole bunch on the side. That's the precipitate that we got out with the centrifuge. And if you look closely through that, and I'll hold my shirt up to see if that makes it better.
Yep.
You can see that the solution is now completely colorless. So we got rid of all that leftover yellow murky color and got all of our sulfides out. And all of our group 2 stuff is in this precipitate on the bottom. If we were doing the general unknown, this liquid, the supernatant, would have your group 3 and 4, and we would save those for later. But since this is just the group 2s, those are just, just whatever chemicals we didn't end up using. Some leftover thiocitamide and byproducts. So we're going to decant that. We're going to pour the liquid out into this. And this is just our waste beaker. And you guys should be happy that you're virtual because this stuff smells so strongly of rotten eggs. Professor French is actively complaining behind the camera. I've spent so much time in the Orgo lab, I've lost half my sense of smell, so I don't mind it, but it's still relatively unpleasant.
Well, our hair is going to smell like this for
Yeah,
three shampoos.
Yeah, we're going to have to shower for like hours tonight.
Yeah.
So there's my garbage liquid. That's our waste. All we have left is our precipitate. So now I add 20 drops of our 0.1 molar ammonium chloride. So I'll add that.
I'm sorry, guys. I'm not very good at this, but... Okay, hold it in front of your lab coat instead of your fly.
3, 4, 5, 6, 8.
Proof that Aaron can count to 20. Sorry.
To be completely honest, that might have been slightly more than 20, but yeah, we got 20. So give this a little mix, get all the precipitate in there so it can react properly. And it's a little hard to see because some of that precipitate is still caught up on the sides, but a lot of it's mixed in, so you kind of just got a black liquid now. And what are we going to do with that? If you hadn't guessed, we mixed it thoroughly, so now we're going to centrifuge it again. There's a lot of centrifuging in this lab. So, alright, so I've centrifuged it after mixing my ammonium chloride, and the solution's clear again. The ammonium chloride was just to kind of wash out anything that might be bad from the precipitate, so we don't really need anything that's in there, so we're once again going to decant that. So here's my waste beaker. And there you have it. Now I just have my black precipitate again, which has all of our sulfides that we're now going to test for. So now we get to the fun part, when we get to test these for the different colorful cations, and it's also pleasant because it now smells significantly less like rotten eggs in here. So, one of these has it. Here it is, the KOH. We're going to add 20 drops of this.
And remember, when he's adding the KOH, when he adds that, he's going to be making the complex ion with tin. So tin 4 sulfide, will dissolve, and the complex ion will form. Apparently that has...
This bottle's dripping though.
loose-
There we go. Now this bottle is hard to squeeze. 3. On the bright side, this is easier to count than the last one.
Yeah, some of our bottles are getting a little old. How many have we made it to?
This is 18. We're almost there. 19. 20. All right. Oh,
And
my
that was
fingers.
the most
hurt
exciting
now.
portion of this video.
Ooh. All right. So we got our KOH, and like Professor French said, that should be dissolving our tin to make complex ion. Give it a go.
There you
Yeah.
go.
Apparently, my Wonderland shirt isn't professional enough, so we got to cover it up with a.
No, it's just as hot when you hold it in front of your face. Your beard is the same color as the precipitate. Sorry, guys.
We love our banter. Okay, so give it a good mix. Stick a stir rod in there to give it an extra good mix. And this time, instead of centrifuging it, we're going to heat it again. Oh, wait. Got to add 1 drop of
Sorry,
thiocitamide.
guys.
Forgot about that. 1 drop of thiocitamide in there.
Sorry.
Give that a good mix again. Get the thiocinnamide going. And now we're going to heat it for 2 minutes. So I'm off to the hot bath. I'll see you momentarily. All right. So as we discussed earlier, we put the KOH in there and all the other stuff, and then we ended up with complex ion for tin, which is in the solution and it's giving us that kind of yellowish color. And then that black precipitate that I'm going to try and stop shaking because it's starting to come loose is all of our other sulfides. So we're going to decant that, and we're going to save the supernatant for later. And by later, I mean the next thing we do. So we'll give it a nice pour. And there you have it. There's our supernatant with our... Am I in shot?
I got my hand in the way. Okay.
So there's our supernatant with our tin in there. I'll put that off to the side. Now, you're never going to get perfectly all the liquid out. As you can see there, there's still a little bit of liquid left in there. Kind of want to get it out. So I'm going to just put some DI water in there. It says about 10 drops. I'm not counting 10 drops from this thing. I'm just going to give a little squirt. Call that 10 drops. I'm going to decant that, and that's just going to go into our waste.
Do we have to centrifuge it before we decant it again?
Does it say centrifuge?
I'm not sure. I don't remember.
It does say to centrifuge it, and looking at this now, a lot of that did come up when I put the wood in there. So I'm going to centrifuge it and decant it, and then it says to do that 2 or 3 times. Once again, we're not going to make you watch me do that 2 or 3 times, so just I'm washing it to get any extra tin and KOH out of there that might mess with these, and then we'll do the rest of our stuff with the tin, and we'll come back to this later.
Am I done?
Yeah, you're done.
Good.
Yeah, so I guess, just so you guys can see, that was the first wash. As you can see, there's still kind of like a tint of yellow to the solution. I buttoned up my lab coat so that it doesn't go in front of my shirt anymore. So yeah, I still got the tint of yellow, which means there's a little bit of the tin solution in there. However, we have plenty of the tin over here, so I'm just going to throw that out. We don't need that little bit. And we're going to do a couple more washes, and we'll come back to this in a little bit. Alright, so if you can hear that noise in the background, we decided to do this step while the other stuff is centrifuging. So we're centrifuging our precipitate from before and continuing to wash it and clean it. But here's our complex tin ion. I keep going above the camera, I apologize. And now we're going to acidify it to get the tin sulfide back out so we can confirm that this yellow color is actually tin, not some other stuff. So, to start with, let's see what our actual pH is. Give it a good dip.
Okay, let me try to get that.
And we do have blue, so we are basic. So we're going to add some HCl. So, let's add a few drops. Let's see what happens. 1, 2, 3, 4. If you notice, I don't know if the camera will pick it up, but we do have some gas coming off there when I put the HCl, and the solution is actually starting to layer. You can see some like cloudy solidness coming out on top. Let's give that a good mix. Fortunately, that did all dissolve back in, so we're not quite acidic enough yet, I don't think.
No.
So I'll keep doing that, and I'll bring it closer to the camera so you can kind of see this gas coming off of it. Go. Let's give it another swirl. And now it's still cloudy after that swirl, so we're probably good. Just to double check, let's take a quick pH reading.
I'm trying to get down to the paper. Poorly, but I'm trying to get down. Ah!
And it did come off as red.
Hang on, I gotta back it up.
Did come off as red, so we have our acidic solution now. So the cloudiness pretty much means it's in there, but let's keep with this stuff anyway. We add, what is it, 5 drops? 5 drops of thiocinnamide. This guy keeps coming up a lot. Gotta love thiocinnamide. 1, 2, 3, 4, 5. I think I might have added 6 in there. Oh well. Give it a good mix. And we will heat for 2 minutes, and I'll bring it back to you to show the final product after that. So if you guys look closely at this, you can now see that we've got a precipitate that's pretty much just this solid chunk of stuff on the bottom. We haven't centrifuged it, so it's not like a full pellet. So it is still, the solution itself is kind of cloudy, but there is a clear precipitate, and I'll bring it a little closer just in case it's not showing up. And there you have it. We have confirmed the presence of tin. It also smells quite badly again, so be glad you're not here. Professor French is complaining a lot about the smell. So
We're going to go get rid of that
we're
now.
going to go get rid of that. We're going to put it over here. We don't want it near us. All right, waving away the smell. Okay, so we've done the tin. Here is our precipitate again after the second wash, and we're only going to wash it twice. As you can see, the liquid is already significantly clearer, so we're pretty sure we've gotten rid of all of the leftover tin and other bad things. But still, because it's a wash, let's get rid of our precipitate, our supernatant rather. We're keeping the precipitate, that's the thing that has all the stuff. So there it goes. So now that I have that, I'm going to add 2 drops of HCl. You can see there is some gas coming off of that as well as we dissolve all the stuff. And from there, we're going to heat again and centrifuge again. There's a pattern going on if you haven't figured it out. Alright, so here's our supernatant. Here's our stuff from before. We acidified it, we put it in the hot bath, and we centrifuged it. We forgot to put water in there, so we did add water in there. So it wasn't just the acid, it was acid and some water. But as we said earlier, now we've made a complex ion with the cadmium. So we should have cadmium in our supernatant, and our precipitate here should just be our other two, the bismuth and the copper. So I am now going to separate these two, and I'm going to save the precipitate for later, and we're going to test the supernatant for our cadmium.
Do you want me to show that?
Yeah.
Yes? Yes?
Alright, I realized I wasn't actually wearing my goggles in the last shot, so I apologize. Safety first, everybody. So, here is my supernatant with my cadmium complex, and we now want to make this basic. So, we're going to add some 6 molar NH3 to it, some 6 molar ammonia to it, but first, let's double check, see where we're starting at. So you can see,
Well, I was zooming in on it. But
got that nice red spot, so we're at acidic. So, here it is. Hello. Make sure that's tight. Oh, I can smell that. If any of you have ever smelled ammonia cleaner, it's also unpleasant. This lab is very colorful and very fun, but oh, it's smelly. So yeah, let's add some drops to that and see what happens, shall we? There isn't a major change like with the HCl earlier, so I put some drops in there and it's fairly concentrated. So I'll give it a swirl. And I'll touch it to the pH paper. We'll see what happens. Came off kind of green, so we're just slightly basic. But I'm getting the thumbs up from Professor French behind the camera, so that'll still work. And also, if you look closely, you can actually see some stuff starting to precipitate out of there. So that's probably our cadmium, but we'll continue with the rest of the step anyway, where we add 2 drops of thiocinnamide, just to get that extra sulfur in there. Give it a swirl.
I don't think we need to heat that.
The instructions technically say to heat it, but look at that. We got that bright yellow color going on there. We've got cadmium. And I'll just let that sit for a second. Before we cut though, I do want to show you really quickly. While we're filming, the tin came out, so I just want to show you that nice clear tin that we got there. So there's our tin. And there's our cadmium, and if we let it sit for a while, it'll also probably just settle to the bottom, and I'll show you that later if it happens. So, next, we'll do the precipitate and get our copper and our bismuth. Okay, so here's our precipitate, and it should have our copper and our bismuth. Like I said earlier, when you decant stuff, you're never going to perfectly get all the solution out. So there's still a little bit of water in there, but that's fine for this one. We don't have to worry about that like the other step when we washed it. We're going to add some more water in, though, so it's not just sitting on the bottom. So I add my water, and I'm going to add 6 drops of nitric acid. Nitric acid is one of the fun acids that will eat your skin off if you get it on you. So
Can you show them the bottle though so they actually see the chemical formula? See?
Yeah,
Nitric
so there's
acid,
nitric acid.
HNO3.
So I'm going to add 10 drops of this, and we'll see if anything funky happens. Ooh, that's coming right out of there. I already stopped counting. I don't know, we'll say that's 10.
10, that's close.
Give or take.
Yep.
It's concentrated acid. At this point,
It's acid in there.
it's acid in there.
Yeah.
So yeah, give it a good stir, and once again, we'll heat for 5 minutes. So, see you momentarily. So here we have our solution now, with and we can pretty much see that there's copper and bismuth in there, but we'll follow the rest of the steps anyway. However, there is still some residue stuff. There's some excess sulfur left over that I don't want anymore. So we're going to stick this in the centrifuge real quick, and we're going to spin it down, and we're going to get rid of that stuff. And then we'll come back, and we'll finalize our tests for the copper and the bismuth. Alright, so like we said earlier, we had that like white stuff at the bottom. We think that was fused sulfur, which we want to get rid of, so we've decanted that over here. However, upon further inspection, it is quite white, so that might actually be our bismuth. So we'll come back to that and see if the bismuth test works over here or not. So if it doesn't work over here, then this is our bismuth. But we're going to try it with this. But first, let's do the rest of the steps to get our copper. If you look at it closely, hold it up to my white lab coat, this is already a kind of a pale blue color. So it's probably some copper stuff in there, but we can make it even bluer. So we're going to add some 6 molar NH3 to make it basic. So as usual, let's check our starting pH.
Very definitely acid.
I forgot to get a clean piece of pH paper, so I'm using a different one, but there's our acid. It's clearly acidic. So let's add some NH3, which is one of these bottles. It's this one. So let's see if anything happens when we do this. And if you look at that, you'll see some nice blue coming out of there. Give it a good swirl.
There comes your bismuth too.
And it kind of disappeared, but like Professor French said, that's also some bismuth probably coming out. So let's add some more of this. Continue to make it basic.
There you go.
If you look at that, so that blue color, I believe, is our confirmation of copper.
Yep, that's the
It's a
copper
very pretty blue
tetramine
color.
complex. Okay, so you're going to spin it down now.
So now I'm going to centrifuge this to get that bismuth that came out to settle to the bottom, so we can do some other stuff with that. Okay, so now that we've centrifuged it, you can see that really pretty blue color. I keep holding it too high for the camera, don't I? I apologize. And in the corner, we have this white powder that's, you know, probably our bismuth, but we're going to do the last test just to be sure. So I'll separate that out. So there's our copper. And here's our, not all of the copper came out, but who's perfect? Not me. Then we're going to wash, precipitate with 10 drops of NH3. I keep wanting to say NaOH, that's the wrong base. So Right, this is NH3? Yes, it is. So. Right, so I put that in there. I'm going to give it a good wash. And let's give it a little more solution to sit in, because that's not a lot. And we're going to centrifuge this one more time to get that nice clear pellet of bismuth out. Alright, so we took it out of the centrifuge, and you still got a bit of a pale blue solution in there, because not all of the copper came out, like I said, not perfect, but it's really pale blue, so it's mostly gone. If you look on the back side, there's our white precipitate, so that is the presence of our bismuth. So just to review, our bismuth is that white precipitate that came out. Our copper is our deep blue solution. Let's get out the cadmium again. That has also fallen to the bottom. We got that nice yellow powder at the bottom and some stuff still floating in solution. And all the way from the beginning, here's our tin as that kind of like beigeish, brownish precipitate all at the bottom. So there it is. Those are the observations for our group 2 ions. Next week we'll do group 3 and 4. Hope you enjoyed this video.
Have a good day.